Eric. I want to show you how to take some measurements on oscilloscopes where you cannot have a ground reference. I just want to show you something just to review very quickly. If I wanted to go to measure the voltage of this battery, for example, I could go to channel 1, and I could connect my ground lead, connect this, and set the scale appropriately on my oscilloscope so I'm not going off the screen. We see with it's a times 10 probe, half a volt per division, effectively 5 volts per division. I'm looking at almost 10 volts here, which is expected for a 9-volt battery. But when I make a measurement like that, I'm doing something very important. This ground lead right here that I'm using to make my reference connection to my voltage source actually connects to the chassis of the oscilloscope, and that connects to earth ground through the third prong, the safety prong of my power plug. That can be a problem. Imagine if you were an electrician, you would like to measure or look at the waveform coming out of your variable frequency motor drive that's somewhere around 480 volts phase to phase, and you want to take your oscilloscope and go here to here with it. Well, you're going to have a problem. The most significant problem you're going to have is not the range of your voltage, but rather the fire that you'll be holding as soon as you make the connection between your ground lead and one of those ungrounded phase connections in the motor drive. Because this lead right here, even though you may think of it as being the black colored lead on a voltmeter, just like this is a red colored lead, this black colored lead actually goes to earth ground whether you like it or not. So every time you make a connection to a circuit like this, you are grounding one part of that circuit, whether you like it or not. You better be prepared for the results. So you cannot be doing phase-to-phase measurements on an AC system, otherwise this thing would be a direct ground fault. And like I said, if you're holding it, it's going to be very, very nasty. But there's a solution, thankfully. And that solution involves the use of 2 probes. You see right here, this is a dual trace oscilloscope. I have a channel 1 and I have a channel 2. So I can show you very briefly how channel 1 works to measure voltage. You've already seen that right there, it's going up. And now I can show you how channel 2 works to measure voltage. I can switch this to channel 2, and now when I touch channel 2 to the battery, I see that line go up. So you see channel 1, you see channel 2. We can also have what's called a dual channel. I can move these 2 lines apart, and now I have one channel that goes up and down. Then without touching any switches, I take my other probe, go to the exact same battery, and I have 2 channels. I can see the top line move now. So I have 2 channels right now that are active. And most people who use oscilloscopes a lot are familiar with those 3 settings: channel 1, channel 2, and dual. However, there's another setting I'd like to show you, and that's add. When you move to the add setting, whatever you see on the screen is the summation of the voltage of channel 1 plus the voltage of channel 2. Now at first that may seem fairly useless until we engage a very useful feature right here, channel 2 invert. So what that means when I hit the channel 2 invert is that any signal applied to channel 2 is going to be made upside down on the screen. A positive voltage of channel 2 now will drive the line or dot down instead of up. So what this means, if they're set to equal volts per division, everything else is equivalent, is that it's going to be measuring the difference or the subtraction. Channel 1 minus channel 2 is what we are now going to see on the screen. Here's how this helps us. I can take this and center my screen now. What I can do now is simply, if I want to, remove the ground clips from my probes. I don't even have ground clips anymore. I just have 2 probe connections. But since my oscilloscope is now going to be measuring the difference of voltage between these 2 channels, look what I have. I have the capability now to measure voltage between 2 ungrounded points. So I can take these 2 clips and go to my battery, channel 2 on the negative, channel 1 on the positive, and up it goes. Or I can go the other direction. I can go channel 2 on the positive, channel 1 on the negative, and down it goes right there. So what I have is the ability now to measure 9 volts DC without forcing either terminal of the battery to go to ground potential. This is something usable in a live AC circuit. Now the only question we have, and the only problem we potentially have, is making sure we have enough range on our inputs with the 10-to-1 probes to measure the magnitude of voltage we're looking for. Once we've got that covered, we've already eliminated the grounding problem. So if you need to make a measurement in a circuit where you cannot afford to force one of those points to hit ground potential, this is how you do it. It does mean that you've taken a dual trace oscilloscope and reduced it down to a single trace, but you get rid of the ground problem, and that's huge. This is not just useful in high power, dangerous circuits. This is also useful for things like communication networks. If you're looking at a communication network, a two-wire twisted pair, where neither of the wires is grounded, say for example RS-485 or RS-422, where it's a balanced, ungrounded differential signal pair, you do not want to forcibly ground one of those communications lines because you'll cause all kinds of signal reflection problems. So this is what you do. You set up the oscilloscope for dual channel with channel 2 inverted in the add mode, and now you can just go across there like a normal voltmeter without any fear of grounding either one of those communication lines, and now you can measure the signal just fine.